Okay, now,
Did you see?
capsule, right? Outer edge is cortex. Inner edge is medulla, of course. Okay, now, pyramid, right? Soul nephrons. Column, in between. That's the connective tissue and the blood vessels, right? Okay, columns, pyramids. Now, each pyramid drains its urine into a minor calyx.
You see, sweetheart?
That's it? Each pyramid drains its urine that it produces into a minor calyx. Here's a minor calyx. Here's one, here's one, here's one. All over, right? Okay, now. Minor calyx, they come together to form major calyces. There's about 3 of them in every kidney. So here's one here. Here's another one here. There's probably another one under there, another one over here, right? So a minor calyx is formed from several minor calyxes. Now, major calyx, they all form, there's like 3 or 4 of them in a kidney, and they come together in the space, right, which is called the renal pelvis. Okay? And this is the renal pelvis right here. Okay, now, the renal pelvis then will go and exit as the ureter. Okay? Now, that's the gross anatomy. Now, each one of these pyramids has many nephrons in it. Okay? So, each nephron unit has 5 components, right? So you have a glomerulus, which is inside a capsule. That's this over here. The glomerulus is actually the capillaries, right? And then you have the capsule, which surrounds it. That's what you see here. And the whole thing is called the renal corpuscle. Okay? So then you have the next section, which is the proximal convoluted tubule, the PCT. Proximal convoluted tubule. The proximal convoluted tubule then straightens out and descends and becomes the loop of Henle. The loop of Henle ascends, right? Ascends back up. And then you have the distal convoluted tubule, this dark green. The distal convoluted tubule, the dark green. You see it? Okay, so you have the dark green, the distal convoluted tubule. Okay, now. Then the distal convoluted tubule ends at a collecting duct, which is here. Okay? And a collecting duct joins up with other collecting ducts. When other collecting ducts join up with it, it's called a papillary duct. Okay? And then a papillary duct runs down, meets up with other papillary ducts, becomes a minor calyx. Okay? That's how it works. Okay, so now, this is a renal corpuscle. Okay? What you have here is the capsule and the glomerulus and the space. Capsular space, okay? This is an artery coming in and an artery going out. This is the afferent arteriole. This is the efferent arteriole, okay? Okay. Now, this is the proximal convoluted tubule. Then you have a distal convoluted tubule coming over the top. See how the distal convoluted tubule is almost always associated with the glomerulus as well. So the glomerulus has 2 sets of receptors in it. One that looks at the blood pressure and one that looks like the filtrate. Okay? It's called the juxtaglomerular apparatus. It's all in here. It's in here. It's on the other model. You can see it better. Where's that other model? Over there. Okay? And then you have, I'll look at it later. And then you have, that's the glomerulus. Okay? Now, now the blood supply. Okay? Yeah. Yeah, it's not very easy to see. It's much better on the other one.
She's talking about the white little hands.
Oh, those are podocytes.
Right.
Yeah. Yeah, podocytes. They cover the glomerulus. What they do is they create the slits. Podocytes, they create slits that are absolutely uniform in size. So, everything underneath a certain size can be filtered. And everything above that can't. That's why you get only water-soluble materials in the filtrate and nothing else. No proteins or anything because they can't fit. Okay, Now, the blood supply. You have the renal artery that comes from the abdominal aorta, right?
Hungry?
So tired. Anyway, so now you have the renal artery, and it branches into two large arteries that are called segmental arteries. Okay? And these segmental arteries then go into lobular arteries, right, in between lobes in a column. And then you have the arcuate arteries. They arch over the top of a column, over the top of a pyramid. And then you have intralobular arteries as these, okay? Okay? And then what happens is these intralobular arteries, which is like right here, they get too small to see. So you have to look on the on the blow up, and then you see the afferent arterioles going into the glomerulus, right? And the efferent arteriole coming out of the glomerulus, okay? Then the efferent arterioles, since it's a portal system, right? Arteries go into capillary bed, giving you other arteries. Then it goes to veins. So then it goes to another capillary bed. The efferent arteriole goes to another capillary bed, which is all this stuff. And that is called the peritubular capillary bed. Okay? Then from the peritubular capillary bed, it goes to the veins and leaves by the same names. Segmental and all out. Okay? Now, the peritubular capillary bed is very important because it's peritubular. It's near the tubules. So this is where all the absorption and secretion is going on with the peritubular capillary beds and the tubules. Okay? So the function of the kidney is really based on this peritubular capillary bed. Really important. Okay? So when, like the distal convoluted tubule here reabsorbs water, where is it getting it from? Peritubular capillary bed. When the proximal convoluted tubule reabsorbs all the nutrients at the homeostatic limits, that's where it gets it from. That's where it puts it in, peritubular capillary bed. Okay? Okay? So it's really important structure. Okay? Right, okay. Because that's where all the physiology is going on, between the tubules and that. Okay? So, yeah, just go over that one two more times, and that'll be fine.